Welcome to The Deep Dive, the show where we give you the shortcut to expertise. This is the DataZen AI podcast, brought to you by the DataZen community. And today, we are tackling a really big one.
We are.
Hugging Face. It's a platform that's, well, it feels like it's completely rewritten the rules for modern AI.
That's absolutely right, yeah. For anyone out there looking to understand, where do these state-of-the-art AI models actually live? How do you get access to them? And importantly, how do you integrate them into real projects, whether you're a coder or maybe you're not?
Yeah.
This deep dive is really designed as your quick start guide. We're going to try and strip away some of the jargon.
Yeah, cut through the noise.
Exactly.
Yeah.
And just focus on why Hugging Face is like the central nervous system, you could say, of open source AI right now.
Okay. So our mission for you, the listener, is really to deliver that quick, thorough knowledge, that aha moment that maybe transforms what feels like a really confusing field
Yeah.
into something you can actually use, like a toolbox.
Yeah.
We're going to show you how easy it is to start leveraging these cutting-edge models almost immediately.
Yeah, shifting the focus away from, abstract theory and more towards practical application.
Exactly.
You don't need to feel overwhelmed by just the sheer volume of information out there.
Yeah.
We've synthesized the core sources to really give you the most important nuggets, the key insights.
Great.
So let's just jump straight in. What is this platform, and why is it dominating the AI conversation?
All right, let's start right at the beginning.
Yeah.
Hugging Face, or HF people call it sometimes.
Yeah.
It's got that cheerful emoji name, right? Yeah. Sebastian. But its impact is pretty serious. What is it fundamentally in the AI world?
Okay, so at its core, Hugging Face is, well, it's a tech company, but it's also this huge collaborative platform, and it's built on these twin pillars, open source and open science. It's really transforming areas like natural language processing, NLP, and machine learning generally by providing this central hub, a place to share, find, and build ML assets.
Assets meaning models, data.
Exactly. Models, data sets, demos. It's way more than just like a file storage place. It's a whole integrated ecosystem designed to make really complex AI much more accessible.
And it's all centered around the Hugging Face hub you mentioned. That's the core kind of marketplace.
Precisely, yeah. The hub is the destination. It's where everyone from, individual students and researchers right up to massive companies, they all come together.
Right.
To access and share models, high-quality data sets, and these interactive demo apps they call spaces.
Yeah.
It just enables collaboration on a scale we really haven't seen before in AI.
And this collaboration, it ties right into their mission statement, doesn't it?
Yeah.
They're quite explicit about it.
Oh, absolutely. Their core mission, they state it clearly, to democratize good machine learning, one commit at a time.
That sounds ambitious.
It is a huge strategic goal. It means taking the most powerful, cutting-edge AI tech, the kind that used to require, massive computing power, expensive teams.
Yeah, locked away in corporate labs.
Right. And making sure that any individual, regardless of their budget or their infrastructure, can actually access it and use it. It massively lowers the barrier to entry for innovation.
Okay, let's unpack this a bit more. Because you hear this analogy all the time. Why is Hugging Face called the GitHub of AI? What does that actually mean, like technically and collaboratively?
It's honestly the perfect analogy because it speaks right to the underlying structure, the architecture. So GitHub, as most developers know, gives you a Git-based hosted repository for code.
Right, for version control, collaboration on software.
Exactly. Hugging Face does the same thing, but for machine learning assets.
And ML assets are notoriously tricky to manage, aren't they? Models can be huge.
Oh, absolutely. They are difficult. Unlike source code, which is mostly small text files, a big language model like Llama 2, it can have hundreds of billions of parameters. The file sizes are enormous, sometimes over 100 gigabytes.
Wow.
Now, Git by itself, it's not really designed to handle those huge files efficiently. And that's where Hugging Face cleverly leverages tools like Git Large File Storage or Git LFS.
Okay, so using Git, but with this LFS add-on, that lets researchers push these massive model weights, track the history of changes, make sure things are reproducible.
That's the key insight, yeah. It makes sure that when you download a model, you know exactly when it was created, what version you actually have, how it's different from older versions. This level of versioning and collaboration built around familiar Git workflows, that's what really fuels the rapid innovation. It lets millions of people build on a stable, version-controlled foundation instead of everyone starting from scratch every single time.
Okay, that deeper look at the infrastructure makes its popularity make a lot more sense.
Mm-hmm.
Now let's dive into the actual components you find on the hub. Starting with just the sheer number of AI resources available. It's staggering.
The scale really is what sets it apart. I mean, when we talk about the models repository, we're talking about the largest collection of its kind anywhere in the world.
How many are we talking?
Well, sources vary slightly, but some indicate over 1 million models hosted there. Or if you focus maybe on the most robust, frequently used ones, you're still looking at nearly 500,000 usable models.
Wow, over 450,000 models ready to go. That really brings up this idea of transfer learning, right?
Exactly.
Given this huge resource,
Right.
what's the strategic value for a developer or a team to use these pre-trained models instead of trying to build their own from the ground up?
Wow. The value is massive.
Yeah.
It's mainly cost and time savings. Think about it. These models, they've already been trained on enormous general data sets. Training them costs a fortune, like hundreds of thousands of dollars in compute time just for that initial pre-training. By using a pre-trained model, you completely skip that really expensive step. Instead, you rely on transfer learning. You're basically taking a model that already understands language or images generally.
And just teaching it the specifics you need.
Precisely. You're teaching it specific tasks rather than trying to teach it, the concept of language from scratch.
And the hub isn't just about large language models, as it covers a much wider range.
Mm-hmm.
Can you break down the scope of tasks available in this model taxonomy?
Yeah, it's pretty much the whole spectrum of modern machine learning. So in natural language processing, NLP, you've got the big ones,
Yeah.
models for things like sequence classification, like sentiment analysis, text summarization, translation,
Yeah.
and of course the generative text models everyone's talking about, Llama 2, Mistral, the GPT family.
Okay, and moving beyond just text.
Then you move into audio. This includes tasks like automatic speech recognition, ASR, that's voice to text,
Okay.
text to speech, TTS, so generating speech from text, and even more specialized things like voice activity detection. Then there's computer vision.
Right, images.
Images, yeah. Models for image classification. Is it a cat or a dog? Object detection. Where are the cars in this picture? Depth estimation, and also generative stuff like image-to-image processing. Think diffusion models for creating art.
And increasingly important, these multimodal models.
Absolutely. These are super interesting. They're designed to handle and sometimes output different types of data. So processing text to generate an image or analyzing an image and its caption together, that area is seeing some really rapid innovation right now.
So with potentially over 1 million options, discovery has got to be critical. How good are the hub's filtering tools? Because navigating that must be a challenge.
Oh, the filtering system is essential. You absolutely need it. You can filter by the specific task you need, which is often where you'd start.
Like translation or image generation.
Exactly. But for developers, the really key filters are more technical. You can filter by the underlying machine learning library, PyTorch, TensorFlow, or JAX. That's crucial for making sure it fits into your existing code.
Right.
You can also filter by the language the model supports, French, Spanish, Japanese, and critically by the license type.
Ah, the license filtering. That seems like a massive strategic point, doesn't it? Especially for businesses.
Oh, absolutely critical.
Yeah.
If a company's building a product, they absolutely cannot afford to accidentally use a model that's restricted to, say, research only.
It's a non-negotiable step for any enterprise use. The platform makes it really clear. You can easily see which models have permissive licenses, allowing commercial use, and which ones are strictly for academic or non-commercial research. That transparency is fundamental for responsible deployment.
Okay. Now, models are kind of useless without good data, right?
Fundamentally, yes.
So that brings us to the second core component of the hub, data sets.
Datasets are the absolute bedrock.
Yeah.
And Hugging Face hosts just an astonishing collection over 300,000 datasets.
Wow.
It covers everything from huge text collections scraped from Wikipedia to really specialized medical images or hours and hours of speech recordings.
And why is having access all this data so important for that democratization mission you mentioned?
Because good models need good data. Simple as that.
Yeah.
And historically, getting your hands on large amounts of clean, well-labeled data, that took immense effort or really expensive subscriptions.
Right.
Hugging Face democratizes this by just providing readily accessible, high-quality data. Often, it's the exact data used to train some of the best models out there.
So if you're a developer trying to fine-tune a model for, say, the finance industry.
Exactly. The availability and the sort of standardization of data on the hub can drastically cut down your development time. You might find a relevant financial news dataset ready to go.
And I hear the experience is pretty user-friendly too. Like you can preview the data.
Yeah, it's great. You can preview sample rows of the data, check how many entries it has, and use this integrated dataset viewer right in your browser without downloading anything first.
That's handy.
It turns data exploration from a chore into a pretty simple exercise. And just like with models, users can contribute their own data sets too, which just keeps enriching this global collaborative knowledge base.
Okay, let's move to what might be the most approachable part for many people, especially non-coders, spaces.
Spaces, yes.
What are they and why are they sometimes called a game changer?
So spaces are basically Git repositories, just like for models and datasets, but they host interactive AI applications that run directly in your web browser.
Okay.
They're kind of the realization of that open source ideal, but packaged up in a low-code or even no-code environment. They're usually built using frameworks like Gradio or Streamlit.
Right, can you clarify what those are? Gradio and Streamlit.
Sure. They're Python libraries specifically designed to make it super easy to build web user interfaces around machine learning models. So instead of writing loads of complex front-end code, you use these libraries to quickly put together a basic UI, maybe a text box, an upload button, a submit button, often in just minutes. Hugging Face Spaces then takes these UIs and hosts them for you on their infrastructure.
So that brings us back to a key question.
Yeah.
How can someone actually use Hugging Face without writing a single line of code?
Spaces are absolutely the answer for that. Yeah, for immediate access, you don't need to install anything.
Nothing.
You just browse the Spaces tab on the hub, find an application you're interested in, maybe a text summarizer or an image generator, click on it, and you can use it instantly. It offers instant access and results. It lets anyone, analysts, project managers, students, curious individuals, test drive thousands of ML apps. It's a really critical tool for just rapid evaluation.
And the examples our sources mentioned really show the power of this.
Oh yeah, think about the practical uses. Like the OpenAI Whisper Space lets you transcribe hours of audio right there. Or for something more creative, there's the AI Comic Factory that generates whole comic strips from just text prompts.
Fun.
Yeah. Or maybe something more cutting edge like the Stable Video Diffusion Space. That takes a still image and generates a short video clip from it. These are complex, computationally heavy ML models.
Running smoothly in a browser.
Exactly. Running seamlessly thanks to Spaces.
And the resources to run these demos, the basic compute power, that's provided for free. That seems incredible for testing.
It is a huge benefit, yeah. Hugging Face provides basic compute for these demos, typically something like 16 gigs of RAM, a couple of CPU cores, 50 gigs of disk space.
That's pretty decent.
It's more than enough for a lot of prototyping and just trying out these complex apps without you having to pay for any cloud servers yourself.
Okay, before we jump into the actual quick start steps, we should probably nail down some essential terminology.
Good idea.
Let's just confirm the core libraries people will encounter when using the platform programmatically, like with code.
Right. The two absolute cornerstones are transformers and diffusers. Okay. Transformers is kind of the original, the core library. It's heavily focused on text-based tasks, translation, summarization, generation, and it integrates beautifully with all the major deep learning frameworks. PyTorch, TensorFlow, and JAX.
And diffusers.
Diffusers is more specialized. It handles the image-based generative tasks, mainly creating and editing images using those diffusion models we mentioned earlier.
Got it. Next up, a crucial processing step for language models, tokenization.
Ah, yes, the tokenizer. This is absolutely vital for preparing your input text. Language models, they can't just read raw words like we do.
Right, they need numbers.
They need numerical representations. Tokenization is that process of breaking down the raw text into smaller units. They're called tokens, or sometimes subwords. What's really interesting here is that modern models on Hugging Face often use these clever subword tokenization methods, like byte pair encoding, BPE.
Okay, and why is subword tokenization better than, say, just using whole words as tokens? What's the advantage?
It's a really smart trade-off. It manages the balance between vocabulary size and handling words the model hasn't seen before.
How so?
Well, if you use every single word as a token, your vocabulary becomes enormous, unmanageable. If you just use individual characters, you lose too much meaning. Subword tokenization breaks down complex or rare words like, say, unbelievable, into common parts like believe, and able.
Ah, I see.
This lets the model process words it's never explicitly encountered during training, which dramatically improves its performance and its ability to generalize, all without creating a ridiculously large vocabulary list.
Clever. Okay, finally, the concept that underlies all the practical use of these models. Inference.
Inference. Yep.
Okay.
Simply put, inference is just the act of using a trained model to make a prediction or generate a result from new input data.
So when I ask ChatGPT a question,
You're performing inference. Exactly. When you use Whisper to transcribe an audio file or use a vision model to classify a new image that's all inference, it's the application stage of machine learning. And its speed, how fast it runs the latency that's really critical for any real-time application.
okay, that groundwork is super helpful. Now let's pivot to the really actionable steps. For someone listening right now wanting to start today, how do they actually begin using this incredible resource?
Right, let's get practical. We begin right at the beginning, setting up your personal gateway to the hub.
Okay, first step seems easy enough. Go to huggingface.co, click sign up, and the basic individual account is free, right?
Totally free, yeah. The community individual contributor account costs nothing,
Simple.
but the bonus you get from signing up, it goes way beyond just basic access. When you create that account, you instantly get your own Git-based hosted repository space.
Ah.
This means you can start creating and managing your own models, your own data sets, your own spaces. It gives you a private area to build up your portfolio, and you can interact with it either directly through the website, which is very user-friendly, or for more advanced users, you can use the command line interface, the CLI, to manage your repos programmatically.
So right away, even as an individual, you get version control and the potential for collaboration on your own projects, like a mini professional setup.
Exactly. It immediately gives you that infrastructure.
Okay, so let's say I just want to dip my toes in. I want to test a model. Maybe I don't know, an analyst, and I want to compare 10 different translation models to see which one works best for my specific text. What's the absolute easiest, fastest way to try a model out? No code involved.
Okay, hands down, the easiest route is to just visit the specific model card page for any model you're interested in on the hub.
A model card.
Yeah, it's like the model's profile page. Most of them include a built-in interactive demo section, usually powered by something called the Inference API. You literally just type or paste your sample input, maybe a sentence for sentiment analysis or a phrase to translate hit compute, and the model processes it instantly, right there in your browser, no setup needed.
Okay, so when I use that little Inference API box on the model card, what's actually happening behind the scenes?
You're basically sending a quick request over the internet to Hugging Face's own hosted inference infrastructure. They have the model already loaded up and running on a server somewhere.
Gotcha.
It gives you immediate results, which is fantastic for just quick checks and evaluations. But it's important to understand the distinction here. This public inference API widget, it's mainly for prototyping, testing, low-volume use.
Right, not for like a production app with thousands of users.
Exactly. If you were building a real application that needed high speed, reliability, and lots of requests, you'd move to something more robust, like a dedicated inference endpoint, which we can touch on later.
Okay. And of course, the other main way for no-code testing is just diving straight into those interactive apps hosted in Spaces, right?
Absolutely. Spaces are the other go-to for instant code-free experimentation.
All right, now for the coders listening, people who want to integrate these models into their own applications, maybe locally or in the cloud, what's the basic setup needed?
Okay, for developers, yeah, a basic local setup is usually the starting point. You need to make sure you have Python installed specifically. Version 3.8 or higher is generally recommended.
Okay.
And you'll need pip, which is Python's standard tool for installing packages. Most Python installations include pip already.
And then installing the actual Hugging Face libraries, is that complicated?
No, it's surprisingly simple. The main command you'll run in your terminal is just pip install transformers. That gets you the core library.
Pip install transformers, got it.
However, to really use the whole ecosystem effectively, especially for loading and processing those data sets we talked about, you'll generally also want to install the data handling bits. So
Yeah.
you'd run pip install tokenizers data sets as well.
Okay, tokenizers and datasets. Where should developers actually write this code? And is there a best practice for managing the environment?
Any standard development environment works great. Jupyter notebooks are very popular for experimentation. VS Code, PyCharm, whatever editor you like.
But the environment part.
Ah, yes, the critical strategic choice here is strongly recommended. Use a virtual environment. Tools like Venva, which comes with Python, or Conda are perfect.
Why is that so important?
It basically isolates the specific libraries and versions needed for this project from everything else on your system. It prevents conflicts, like if one project needs an old version of a library and another needs a new one. It just keeps your workspace clean, organized, and crucially reproducible.
Makes sense. And what if someone's facing hardware limitations, maybe doesn't have a powerful laptop, or just wants the absolute fastest way to start coding without local setup hassles?
Then Google Colab is an absolutely fantastic option.
Right.
It's free, it runs entirely in your web browser, and it often gives you access to powerful hardware like GPUs for free, at least for basic usage. You can completely skip the local installation, just open a Colab notebook and type .pip install transformers right into a code cell, and you're ready to start coding immediately. It's great for learning and quick tests.
Okay, this feels like the moment we go from setup to actually using the models in code. And Hugging Face apparently makes this incredibly simple with something called the pipeline method.
Ah, the pipeline method.
Yeah.
Yes. Provided by the Transformers library, this is arguably the single most important convenience feature for developers starting out.
Why is that?
It's a really easy-to-use, high-level API. It basically abstracts away all the complex boilerplate code you'd normally have to write.
Like what kind of boilerplate?
Things like fetching the right model files, loading the massive weights into memory, doing the specific tokenization needed for that model, running the actual prediction logic, and then decoding the output back into something readable. The pipeline handles all of that automatically.
So you can get results with minimal code.
Exactly. Perform inference across tons of different tasks. Language, vision, audio, often with just a few lines of Python.
Okay, let's make this concrete. Give us a specific practical example. How about sentiment analysis classifying text as positive or negative?
Perfect example. Simple and common. So for this task, you'd start your Python script by importing the pipeline function from Transformers.
Okay.
Then you create a pipeline instance. You tell it the task you want, sentiment analysis, and then you usually specify which pre-trained model you want to use. For speed, a lightweight model like Distilbert-based uncased fine-tuned Stowe-2 English is a popular choice.
Right, Distilbert. Why choose that one over, say, the full, larger BERT model? What's the strategic thinking there?
Good question. Distilbert is, as the name suggests, a distilled, smaller version of the original BERT model.
Okay.
It's significantly smaller, it runs much faster, uses less memory, but the key thing is it only has a very small drop in accuracy compared to the full BERT on most common tasks, like sentiment analysis. So for things like rapid prototyping, or maybe building an application where low latency is important, like responding quickly in a chatbot, choosing a lighter, faster model like Distilbert is a standard strategic optimization. You trade a tiny bit of accuracy for a big gain in speed and efficiency.
Makes sense.
Yeah.
And the code itself is really compact then.
Yeah.
You just call the pipeline function you created, pass in your input text,
Yeah.
and you get the result.
Exactly. It's incredibly concise. You just call your pipeline variable, maybe classifier like this. Result, classifier. This restaurant was okay, but the service was slow. And that's basically it.
And what does that result look like? What information do you get back?
The output is typically a list containing a dictionary. For our sentiment example, if you put in that lukewarm review, the pipeline would likely return something like label, negative, score,
Yeah.
0.9996.
Okay, so you get the label negative in this case and a confidence score.
Right. And that confidence score is really vital. It tells you not just what the model predicted, but how certain it is about that prediction.
So you could use that score.
Absolutely. You could build logic around it. Maybe if the score is below, say, 90%, you flag that input for a human to review it because the model wasn't super confident. It adds a layer of robustness.
That is a powerful shortcut. Okay, let's see another example, maybe something not text-based, just to show the versatility of this pipeline method. How about automatic speech recognition, ASR, transcribing audio?
Great choice. Shows the breadth. So for ASR, we keep the same basic simplicity. You import pipeline, you create a pipeline instance, but this time you specify the task as automatic speech recognition.
Okay.
And then you pick a suitable model. OpenAI's Whisper models are very popular and robust, so maybe you'd specify model OpenAI Whisper Small.
Got it. And instead of text, you give it audio.
Exactly. Instead of passing a string of text, you'd provide the path to an audio file on your computer or even just a URL pointing directly to an audio file hosted online, maybe like a short clip of a famous speech.
And Whisper itself is known for being really versatile with audio, isn't it?
Oh, incredibly versatile, yeah. Whisper was trained on this massive, really diverse data set of multilingual audio from the web.
So it handles different languages, accents.
Pretty much. Unlike a lot of older ASR models that were very specific, Whisper is inherently pretty robust against different languages, various accents, background noise, all sorts of real-world messiness.
And the pipeline makes using it easy. What's the output?
Yeah, the pipeline method hides all that complexity. Even though it's processing complex audio data, the developer just gets back the clean transcribed text as the output. So if you fed it that MLK audio clip, the output might just be a dictionary containing the text. I have a dream that one day this nation will rise up and live out the true meaning of its creed.
Wow. So the beauty here is that the fundamental API call, the pipeline structure, it stays almost identical, whether you're doing sentiment on text or transcription on audio or maybe even image classification.
That standardization is the integration shortcut. That's the magic of the pipeline. It ensures that once you learn that basic methodology, you can swap out different models and different tasks really effortlessly just by changing the task string and the model name.
Okay, we've covered the quick start pretty well, I think, for both beginners and coders getting their feet wet. But the real power of a platform like Hugging Face often lies in going beyond just using the models as they are. Let's talk about tailoring them, specifically through fine-tuning.
Right. Fine-tuning. This is really the critical next step for professionals or anyone wanting to adapt these models for specific needs. It involves taking one of those, nearly 500,000 pre-trained foundational models and essentially retraining it, but only for a relatively short period on your own specific, usually much smaller, custom data set.
And what's the main purpose of doing that? Why fine-tune instead of just using the general pre-trained model?
The purpose is achieving domain specificity. Think about it. A model trained on general internet text, like Wikipedia and news articles, it's probably going to perform pretty poorly if you ask it to understand highly specialized internal company documents.
Like legal contracts or medical records.
Exactly. Or maybe proprietary engineering reports. Fine-tuning allows the model to learn the unique terminology, the specific style, the context of your data. It helps it achieve far better performance on your unique tasks than the general model ever could. It's basically customization, but without that enormous cost of training a whole model from scratch.
Okay. And which Hugging Face tools help simplify what sounds like a pretty complex training process.
The process generally relies on two key library components from the ecosystem. First, the datasets library, which is brilliant for efficiently loading, preparing, and pre-processing your custom data.
Right, getting the data ready.
And second, the trainer API, which is provided by the Transformers library itself.
Okay, the trainer API. What exactly does that do for the developer? It sounds important.
It's hugely helpful because it manages the vast majority of the complexity involved in the actual training loop.
How so?
Well, instead of you having to manually write all the PyTorch or TensorFlow code to handle things like looping through batches of data, calculating gradients, updating the model weights, managing optimization steps, logging progress, saving checkpoints periodically, running evaluations.
Wow, okay, that's a lot.
It is a lot of boilerplate. The trainer API abstracts nearly all of that away. The developer basically just needs to provide the model they want to fine-tune, their prepared data set, and some training configuration settings like learning rate, number of epochs. And the trainer pretty much handles the entire life cycle of the training run. It makes fine-tuning much more accessible.
Okay, that's powerful for individual developers. But here's where I think it gets really interesting for businesses. How do actual teams, product managers, analysts, developers working together in a company, how do they use Hugging Face in real-world projects and, crucially, in production environments?
Right, enterprise usage. Teams typically leverage Hugging Face strategically across maybe three main phases. First is often rapid prototyping and experimentation.
Using the hub to try things out quickly.
Exactly. Using the hub to quickly evaluate different foundation models, maybe test a few quick fine-tuning runs, and select the best approach for their problem without a huge upfront investment.
Okay, phase 1, exploration. What's next?
Phase 2 is often internal collaboration. So once they've maybe fine-tuned a model on their proprietary data, they need a way to share that model securely within their organization. Hugging Face allows organizations to create private repositories on the hub.
So they can use the same Git-based version control, but keep their custom models or data sets private to their team.
Precisely. They can share their fine-tuned proprietary models, maybe internal data sets, securely within their org using all the benefits of version control. And then phase 3 is deployment. getting it into production.
Right. Let's talk about that deployment infrastructure. How does Hugging Face help get these models actually running and serving users?
Okay. They offer a couple of primary routes for deployment. They have their own managed services. We mentioned the basic inference API for testing.
Yeah, the one on the model cards.
Right. But for serious production use, they offer inference endpoints. These are dedicated, scalable, secure, high-performance services, specifically designed for low-latency, high-throughput production workloads. You basically point it at your model, public or private, on the hub, choose your hardware, and it handles the rest.
But what about companies that are already heavily invested in a major cloud platform like AWS, Azure, or Google Cloud? Do they have to use Hugging Face's endpoints?
No, not at all. And that's key to their success. Seamless integration with existing cloud infrastructure is vital. Hugging Face models and their libraries are designed to be easily exported and deployed directly onto all the major cloud ML platforms.
Like AWS SageMaker or Azure ML?
Yes, exactly. AWS SageMaker, Azure Machine Learning, Google Cloud Vertex AI, they provide specific tools, containers, and extensive documentation to make sure that models you find or fine-tune on the hub can be deployed securely and managed entirely within your company's existing cloud environment and security controls.
That flexibility seems crucial for adoption. And for organizations, managing who can access what the models, the data, that must be important too.
Oh, absolutely essential. The platform has comprehensive features for organizational use. Teams can join or create organizations on the hub.
Okay.
This is fundamental for managing collaborative work, controlling access to private models and data sets, and setting up robust permission management. You can define roles, control who can read or write to specific repositories. It includes proper authentication protocols and fine-grained access control, which is critical when you're dealing with sensitive model weights or proprietary corporate data.
And that focus on integration, it extends beyond just the big cloud providers, right?
Yeah.
It plays nice with other common ML tools.
Yes, definitely. Hugging Face compatibility is a big selling point. They ensure that models from the hub can easily plug into other widely used NLP and ML libraries, things like SpaCy, NLTK, even integrating with core frameworks like TensorFlow and PyTorch, beyond just the Transformers library itself. This means developers can often incorporate these state-of-the-art models without having to completely rewrite huge parts of their existing code bases.
Okay. Before we wrap up this section, we absolutely have to touch on responsible usage and security. Since so much is open, how does the platform encourage or enforce responsible deployment of these powerful models?
It's a critical consideration, and they do address it. Security and transparency are key features. As we talked about earlier, that license filtering is step one, making sure users are aware of and adhere to any restrictions on commercial use.
Right. Check the license.
Always check the license. Additionally, the model cards, that documentation page for each model, are increasingly expected to include detailed transparency information.
Like what kind of information?
Things like potential biases identified in the model, known limitations, details about the data it was trained on, maybe ethical considerations. The platform really emphasizes that users need to take responsibility for understanding and mitigating risks associated with the models they choose to deploy, and it tries to arm them with the necessary information via these model cards.
Got it. So it's about providing transparency and tools, but the ultimate responsibility lies with the user deploying the model.
Exactly. It fosters informed, responsible usage.
Okay, finally, let's broaden out a bit. Hugging Face isn't just a repository or a set of tools. It's also a massive educational resource and community hub, isn't it?
Oh, absolutely. This is one of the biggest contributions to the field, I think. They offer truly world-class and completely free online courses.
Free courses.
Yep. Things like their main Hugging Face course, the LLM course, the agent course. These are comprehensive professional-level curricula. They're hands-on, built around practical examples using Jupyter Notebooks or Google Colab. Honestly, they provide the kind of education that could easily cost thousands of dollars elsewhere, all accessible for free.
That's incredible. And for people maybe looking to get into AI or advance their careers, the platform itself could be a tool for that.
Definitely. It offers a huge benefit for portfolio building. Because the hub is public, for your public repos at least, it allows you to create this professional, visible portfolio showcasing your work.
Like showing off the models you fine-tuned.
Exactly. The models you've fine-tuned, the cool interactive spaces you've built, maybe data sets you've cleaned and contributed. Having this verifiable, hands-on portfolio linked from your resume is a massive asset when you're applying for AI-related jobs. It proves you can actually do the work.
And what if you get stuck while you're learning or building? Is there support?
That's where the community comes in. It's probably the strongest safety net. Hugging Face has cultivated an exceptionally active and helpful community.
Where does this community hang out?
Across various platforms. Their own forums on the Hugging Face website are great. There's a lot of activity on GitHub in the issue sections of the libraries. They have very active Discord channels for real-time chat and help.
Okay.
So whether you need help troubleshooting a tricky fine-tuning error, or you just want to bounce ideas off other people, or share a cool new application you built, that collaborative spirit is really strong. You're almost never building completely in isolation. There's usually someone who's faced a similar problem or who's willing to help.
Wow. This has been a really practical and quite fascinating deep dive into the world of Hugging Face. Let's just quickly summarize the path we've kind of laid out for the listener today.
Sure. We started by establishing the foundation, right? Understanding the Hugging Face Hub as this essential Git-based repository, the GitHub of AI, hosting those core components, millions of models, hundreds of thousands of data sets, and those instant no-code demos called spaces.
Then we mapped out the path really from beginner to builder, starting with that super easy non-coding access using the inference API right on the model cards or just playing with spaces. And then for developers, setting up Python, installing the key libraries, transformers, datasets, tokenizers, and crucially, leveraging that incredibly simple yet powerful pipeline method.
Yeah, using the pipeline for all sorts of tasks, from sentiment analysis with efficient models like Distilbert, right through to complex things like automatic speech recognition using OpenAI's Whisper.
And finally, we touched on the more advanced applications. Moving beyond basic use to fine-tuning models on your own custom data, using tools like the Datasets Library and the Trainer API to manage the complexity.
Right. And understanding how teams and enterprises use Hugging Face in the real world for that rapid prototyping, secure internal collaboration on private repos, and robust production deployment using inference endpoints or seamless integration with major cloud providers like AWS, Azure, and GCP.
Plus the importance of the community and the amazing free educational resources.
Absolutely. Don't forget the learning and support aspect.
Okay, well, we really want to thank you for tuning into this deep dive. This has been our Hugging Face Quick Start, part of the DataZen AI podcast.
Yeah, and if you enjoyed this breakdown, if you found these insights useful, please do remember to subscribe to the DataZen AI podcast. You can find us on Spotify, Apple Podcasts, or, wherever you usually get your podcasts.
Yep, your subscriptions really help us keep making these detailed deep dives.
They do.
We're also always really eager to hear your feedback, and especially your suggestions for future topics.
Yeah.
What else should we dive into? So please, feel free to reach out to us via email with your ideas.
Please do. And we'd also invite you to visit our website, datazen.top. You'll find more great content there from the DataZen community, things like articles, info on meetups if you're local, and other tutorials that often expand on the topics we cover here.
Okay. Before we sign off, I want to leave you, our listener, with just one final, maybe provocative thought to mull over.
Okay, so think about this. Hugging Face didn't just build another website or another software library. They really architected a whole new philosophy for how AI development happens.
A philosophy.
Yeah. Consider the really profound implications of having these incredibly powerful state-of-the-art models and these immense cleaned datasets resources that were, just a few years ago, basically locked away inside giant corporate research labs.
Right, totally inaccessible to most.
Exactly. And now they're instantly accessible, often on your personal laptop, maybe via a few simple Python commands or just clicking around in a web browser. So the question to ponder is, what entirely new category of applications becomes possible? Maybe hyper-localized, super-personalized, small-scale niche applications. What becomes economically and technically feasible when the collective intelligence of global AI research is truly democratized like this? When the power to innovate shifts from just a few centralized labs into the hands of millions of individual builders all around the world? That might be the real long-term transformative power of this Hugging Face revolution.